So today I'll be presenting our work on mutation testing using a tool called Java PI test. This method goes a step beyond regular testing to evaluate how strong and effective our test suite really is. So, what is mutation testing? Mutation testing is a way of testing our tests. So we introduced a small intentional change called mutations to our code, our source code, like flipping an operator or changing a constant. Then we run our test suite to see if it can detect these changes. So, why do we use mutation testing? There are four main reasons why mutation testing is valuable. First, it detects weak tests. It helps us find tests that pass even when the code is incorrect, and find untested code paths, even if line cover is high. Mutation testing can reveal missed conditions or branches. It improves test quality. It pushes us to write stronger, more meaningful tests by revealing what they don't catch. It also increases confidence, like knowing your test can catch subtle bugs, give you more trust in your code base during development. Now, what is Java PI test? PI test is a popular and open source mutation testing tool made for Java projects. It integrates easily with Maven and supports common testing frameworks like JUnit and TestNG. It provides detailed HTML reports and a mutation source that show how many mutants were caught by your test. Now, how does PI test work? So first, it scans your code. For places it can mutate. It creates mutants by making small changes, like changes plus to minus or flipping a condition. Then it returns your test against the mutated code. And if a test fails, the mutant is killed. If it passes, the mutant survives. Then it generates a report that shows all the results and calculates a mutation score. A mutation score is killed mutants divided by total mutants by 100%. Now I will show you how I set up my PI test in IntelliJ. So first we open our project in IntelliJ. Then it prompts us to install the PI test plugin. We configure the plugins, then we say okay, and then we install all dependencies we need, like a JUnit Jupyter plugin or all the plugins we need and dependencies. Then we're good to go. Now I show a live demo running.
Hello, I'm Fida Al-Haki, and in this part of the presentation, I will introduce our target code base and walk through the unit test I implemented. These tests are used to evaluate the effectiveness of our code under mutation testing using the PIT. The code we use for mutation testing is a simple but structured Java class called student info, located under JUnit package. It's include four methods. The first one is adult, retain it true. If the given age is 18 or older, else it will retain false. Full name, retain a full name string, combine two parameters like the first name and the last name. The third one, valid email, check if the email is not null, is not empty, if it's contain the if it's contain the U Ottawa, because we specify for a student at University of Ottawa. The third one, which is get a student score grade, maps numeric score to letter grade from A to F, while handling also the invalid and the null values. This is for student info. Now let's see the student info test. I wrote a suite of JUnit test case to validate this method under both typical and edge conditions. First, we test the is adult here. We test legal adult age boundaries, so exactly 18, greater than 18 and below the 18, to ensuring if functions properly. Also, we test full name tests like these two. Test verify correct concatenations of name, and also handle edge cases like both parameter being empty, like this case. And also about the valid email, we have these. Yeah, okay. from here and until here. So we simulate valid and invalid formats such as missing the at also, or missing the dot, not U Ottawa email, not include the U Ottawa. All this to ensure the validation is strict and domain aware. And also the last test cases, which is about student score grade. We test a variety of valid input from 95 to 15, as well as invalid input, like here null and yeah, for here nulls and out of range. Okay, so for here minus 5, which is invalid values, and 105. Okay. Three of our test case go beyond what covered in the BIT tutorial, and are designed for edge case and robustness. First, we have test full name empty names. Check how the method handle empty string input. This is important for ensuring graceful behavior when users submit form without, for example, entering the name. And also, the second one, test valid email, invalid no U Ottawa, which means this one. Enforce a domain rule, a domain specific rule that the email must include U Ottawa. This simulate in situations valid beyond basic format checks. The last one, which is get the student score grade, not input. Yeah, which is this one, ensuring null input do not cause exceptions, and instead the method retain invalid score, providing the code is null safe and defensive. These tests are strategically designed to simulate real-world errors and make our test suite more comprehensive.
So after installing all the dependencies that we need in order to run the bit test, we now can run our test and see the results and the report. So first of all, I will run the test to make sure that all the test passes in a regular mode. So you can see here that all our tests passed successfully. 12 tests passed out of 12 tests, out of 12 total tests. And now I can run my bit test configuration. So once I run the tests, I will see here the results and the link to the report. We can see here from the statistics that for the line coverage for mutated class only, I got 50 out of 51. That's 98% of the lines. And I can see that 49 generated mutations and 24 of them were killed only. That's 49%. And here I can open the report for the testing in the browser. So once I open the report, you can see here a report showing all the details that we need. I can see for the line coverage, as mentioned before, we covered 50 out of 51 of the lines in our code. And for the mutation coverage, as before, we can see that 49% of the mutant were covered. And for the test strength, we can see that our test strength is 49%. So here we can see the breakdown by class as well. So the same results and the same info for each of our classes, the production class and the test class. So if I click here on the test class to see further details, I can see here in the green lines that the mutants that were successfully killed, and on the red lines I can see the mutants that failed to be killed. So the mutants that failed to be killed, what does that mean? That means our test cases passed for mutated code when it shouldn't pass. So the mutants are the mutated versions of our code base, and they shouldn't pass for the same tests. and if they passed, then we have an error in the test cases. Then we have a logical error or a operational error in the test cases that we have. So for this code base, for these tests, we have intentionally added a lot of tests, and we added some of them are faulty just to demonstrate the difference between killed and survived mutations. And here at the bottom of the page, we can see a list of all the mutations that survived and the assertion that gave these survived mutations. And here at the end, you can see the tests that were examined, which are the same tests that we run at the beginning, and all of them passed the 12 tests.